start off a little bit first with the similarity. Are you comfortable with the concept of similarity?
Yes, ma'am.
All right. Let me just start off a little bit with that first, okay? One
Okay.
second. Try. Is the screen visible? Can you see an empty screen?
Yes, ma'am. I can see the screen.
All right. Okay. So I'll basically do a little something with respect to similarity. Okay. Now you're conversant with the idea of congruency. Similarity is something similar to that, but in congruency, what we do is, let's say if I'm talking about two shapes, then we say that these two shapes have to be identical in all respects in case of congruency. So if I'm talking about, let's say, a circle, okay, then this circle is congruent to another circle which has to have the same radius. Similarity is slightly different in the sense that two particular shapes are similar to each other if one is an, let's say, an enhanced or a magnified image of the other. So this this circle will be similar to another circle like this, which has a different radius. So let's say the radius of this is R1 and the radius of this is R2. Then we can say that these two circles are similar to each other. So similarity is when two shapes are such that one is an enhanced or let's say a magnified image of the other. Now when we're doing triangles, I'd say that a triangle like this is similar to another triangle like this if it satisfies. I'm sorry, this yes, I'm sorry. Were you saying something?
No, no, ma'am.
All right. Okay. So these two triangles, I would say that they are similar to each other if this angle is equal to this angle,
Yes.
this angle is, let's say, equal to this angle, and I have maybe this angle is equal to this angle. Now, anyways, if we have two triangles and I have two angles of the triangle which are equal, like in this case, then by default the third angle is going to be equal because, as you are aware, the sum of all the angles in a triangle is equal to 180. Okay, so I have
Yes.
a triangle ABC and this is a triangle DEF. So if I say that angle A is equal to angle D and angle B is equal to angle C, then automatically angle C will be equal to angle F. Okay. Now, like in congruency, we have different rules to prove that two triangles are congruent to each other. We have the same in case of similarity. Couple of rules. In similarity, the rule which is most commonly used is called an AA rule, which is basically an angle rule of similarity, which is if I can prove that two corresponding angles are equal, then I can say that the two triangles are similar to each other. Now here I would write that triangle ABC is similar, this is the sign for similarity, to triangle DEF. Okay, what this means is that angle A is similar to angle D,
E.
angle B is similar to angle E, and angle C is similar to angle F in the sense that these angles are equal. Now, in congruency, if two triangles are congruent, the sides are equal. In similarity, if two triangles are similar, the sides are in proportion. They are not equal, but the corresponding sides are in proportion. So here I would have AB
Mhm.
by DE should be equal to BC by EF, and that should be equal to AC by DF. Okay, so
Yes.
the angles will be equal, but the sides will be in proportion.
He said
All
so.
right. Now, okay. Now, what I showed here was basically using the AA rule of similarity. There are various other rules, like I have something called the SSS rule of similarity. Remember, in similarity, sides are not equal, but sides are meant to be in proportion. So, if in a data I am given a triangle like this, and I'm given another triangle, let's say like this, and I have AB as the length of AB is given to me as 5, length of DE is given as 10, let's say BC is 2,
Sister, you can go out to front line.
EF is 4, and let's say AC is given as 3, and DF is given as 6. Now, if you see, the dimensions are different in the two triangles, but if I find the ratio AB by DE, then that is 5 by 10, half. And if I do BC by EF, then that is also 2 by 4, which is again equal to half. And if I do AC by DF, then that is also equal to half.
I'm gonna
So
help
therefore,
you.
the proportions
I know this minister that's
the proportions of the corresponding sides of the triangle are all equal to half. So because the corresponding sides are in proportion to each other, I can say that these two triangles are similar to each other. That would, I have used sides to prove similarity, but once I have proven similarity, it would also mean that their corresponding angles are equal. Though I do not have data on the angles, but once I have proved similarities, I can infer that the corresponding angles of the two similar triangles are also equal to each other. So we did AA, which is angle angle. This is side side side, and there's also, like incongruency, a rule called SAS, which is basically a side angle side rule, where the angle is the angle in between the two given sides. Again, remember that the sides are meant to be in proportion. They are not going to be equal to each other. Okay, is this all right?
Yes, ma'am.
Okay. Now, there's also another property in similarity that we use in sums, which is that if two triangles are similar, then their areas, that is the ratio of their areas, so area of, let's say, triangle 1 to the area of, let's say, triangle 2, the ratio of the areas between the two triangles will be equal to the square of the ratio of their sides. So like in the given triangle, if I have AB and DE in proportion, then the ratio between the area of triangle ABC to the area of triangle DEF in this particular case will be equal to the square of the ratio of their sides. Okay, so I may not have all the data regarding the triangles, but then because I have the data with respect to their sides, I will also be able to find the ratio between the areas of these two triangles simply on the basis of the ratio of their sides. This is a property which is very commonly used to derive the relationship between the areas of two triangles when we know or when we can prove that these two triangles are similar to each other. Okay. Achha. Now, moving on, you were basically talking